So before you joined, we were looking at sampling. Okay, we were looking at sampling, and we looked at, first of all, determining the sample size that will be representative enough for your study. So, and in doing so, we used two different methods. But before that, even before that, we looked at the two main different types of sampling. If you remember, um, when we started looking at sampling, we talked about the probability sampling techniques, and then we talked about the non-probability sampling techniques. I hope you remember these.
Yes, sir.
Good. I'm going to ask because I asked before and your colleagues disappointed me. I hope you don't disappoint me. When do you use the probability sampling techniques?
That is when the probability you want is structured, is you want to follow some sort of a standardized or systematic way
Okay,
to reach at your conclusion.
okay. So, um, that's a good try, but not quite there. So,
Okay.
um, when I asked, you are right in a way. Yes, you are right, but that's not quite what I was looking for. The probability sampling techniques. Cephas mentioned when I asked that it is when you want to do your sampling in such a way that everyone has an equal chance of being selected.
Okay. Okay.
That is one part of it. Yes, you use it when you want everyone to have an equal chance to be selected. But for everyone to have an equal chance to be selected, then you need to have access to a list for all the people that have an equal chance to be selected.
Yes, sir.
And good. And that list, do you remember the fancy name we gave it the last time? We gave it a certain fancy name, the list.
I remember, but not maybe specific, but I remember that we learnt about it.
Right. So that list is what we call the sampling frame. The
The
sampling
sampling.
frame. Yes, that is the technical term for the list of people. Now, before you do the before you start the sampling, you need to have even defined your remember the target or theoretical population.
Yes. Yes, sir.
Then
Yes, sir.
you get the steady population, also known as the accessible population. Then it
Yes,
is
sir.
based on that accessible population that you get the sampling frame. So the sampling frame you get should include everybody in your accessible population.
Yes,
Then
sir.
it's from that sampling frame that you would pick your sample from. And that sample would then be the people you will include in your study.
Yes, sir.
Now, now when you have the sampling frame, the issue now is how many people, that is if you are using any of the probability sampling techniques that are listed down here. If you are using any of
Okay.
these, that is when you use the sampling frame. But once
Okay.
you've obtained the sampling frame, the question now becomes how many people from that sampling frame am I going to include in my study? In other
Yes.
words, what should be the sample size? In
Uh-huh.
determining the sample size, we there are several ways of determining the sample size. But the common ways, at least for our level, for your level now, is by using the Kretzy and Morgan table, where
Okay.
they specify for this a number of people in your accessible population. Select this number to this number. If you select this number, they will be representative. If
Oh,
the
okay.
accessible
Yes.
population is this number of representative. So That is for
Yes.
Crécy and Morgan. And those numbers were calculated using like a formula, which they don't want to bore us,
Okay.
you and I, they don't want to bore us with it. So they've just calculated the numbers. So that is
Okay.
for Crécy and Morgan. There is a second way of determining the sample size using percentages. So
Okay.
the percentage method is when you say that if your sample size for the whatever sample size you have, calculate this percentage. Take this percentage of that sample size, and they will be representative for your study. So people have proposed different percentages. One popular
Okay.
one is one that was proposed by a scholar called Amadahe, which I am thinking is a Nigerian. I'm not sure, but
Okay.
he proposed that we use 10% of the accessible population for our study. That was by Amadahe 2001. Okay,
Okay.
so first of all, we are going to look at determining the sample size using the Krebsey and Morgan table, and then we are going to look
Mm-hmm.
at it using the percentage way of
Okay.
calculating for it. Now,
Okay.
if you go to the page, if you go to the page here, you would realize that we have I've pasted these few files here. So I
Yes.
want you to open, for example, you can open the sampling frame for SMS, sampling frame SMS.
Okay.
Yes, so if you open sampling frame for SMS, you have
I
a
have
list.
sample. I
Yes,
have the 400. Okay, the SMS is here. Okay,
good,
I've
good.
seen it. Okay.
So if you have the SMS and you open it, you see this is how a sampling frame would normally look like. Definitely, there will be additional information. This list you are
Okay.
seeing is index numbers for School of Medical Science students some time ago. Some have completed,
Okay.
but if let's say you are conducting a study and your target population is medical students, and then
Okay.
your accessible population is medical students in, let's say, UCC, because you have easy access to them, and you want to
Okay.
use any of the probability sampling method, you would have to go to
Okay.
School of Medical Science and request for a list of their students, which will be your sampling frame.
Yes.
Good. That list will look something like this. So they will provide you
Okay.
with the serial numbers and then the index numbers and maybe their names and maybe their phone numbers, so that whoever you select, you can contact the person.
Okay.
Good. Now, once they furnish you with this, you would have to then check how many people are in the sampling frame they have given you, which is normally a
Okay.
number you would even know. So School of Medical Science will tell you that we have this number of students in our school, and this is their list. So once you have the number of students in the school, you can then use the Crécy and Morgan to determine the number which will be representative for that for all medical students in School of Medical Science. And so
Okay.
if you check I have also put, oh, I just closed that. But if you check, I have put this Crécy and Morgan table on the page. You see Crécy and Morgan sample size, Crécy and Morgan.
Okay. Let me check.
Yeah, so check.
Uh,
That should be the first file before SMS.
oh, okay.
Yeah.
Um, yes, please. I've seen it.
Yes. So once you have once you open the file, you realize that at the top we have N, and then we have S next to it. Then we have NS at the top, and then you have
Yes,
numbers.
sir.
So the N you are seeing, the N, the numbers here are the accessible population. So these are the now this is the number for the accessible population. Then the S here is the associated sample sizes for those accessible population. So according to Krejci and Morgan, 1970, if you have an accessible population of 10, you are you would have to select all 10 of them in order to reduce error in your findings, in your results. So 10 would be
Okay.
representative enough for an accessible population of 10. You have to select all of them. If you have an accessible population of 15, then you can select a sample of 14 and they can represent the results. You can generalize to the 15. Like the 4 is representative enough for the 15. If you have an accessible of 20, select a sample of 19 in that order.
Okay.
Okay. Okay, now if you have, so it's the same thing. If you have a sample of 2200, you would have to select a sample of 327, right?
Where is the 300 and
So what is, you would see an n that has 2200. I want you to find that n. So
2000?
200, yes.
I've seen you've highlighted it. Yes, yes. And then
Uh-huh.
you have the 327.
Yes, beside it
Yes.
right here. Good. So this is
Yes, sir.
how you determine the sample size for each accessible population using the Krejci
Based
and
on,
Morgan. Yes, based on the
okay.
Krejci and Morgan table. So what will be the sample size for, say, an accessible population of 380?
3838. 338. We have 3,000, 3,500 or 380.
Is the sample size for 380 will be
That would be 4,000. Or is it 400,000 or 40,000? 40,000.
uh the what is the this is the 380 I'm giving you is the accessible population.
Oh, okay. That
So
is 191.
good.
Is that 191? Okay, I was at the other side.
Yes. So that's why I intentionally
Uh,
didn't highlight it. 380, the sample size is 191.
Yes,
Okay.
please.
What about the sample size for 7,000?
7,000.
Yes.
Seven. Okay, the it will be 248. That is
Two
the that.
seven 248.
Yes, please. Would that be your sample size or your?
Okay. Just a second. What did I say the accessible
Okay,
population was?
7,000.
Okay. I want you to double.
700.
Yeah, I actually said so. I said an accessible population of 7,000.
1,000 rather.
Yes, yes.
1,000. There's no 7,000 here. We have the 700.
Okay.
Um,
Are you sure? Check the table
the other
very well.
side.
Yes,
Okay, we have it will give you 364.
exactly. So, yeah, the seven is actually the table. The table is all the way up to a million. So, yes, you get 300 and what? 64 as your sample size. Now,
Yes, sir.
what would be the sample size for 220? Hey, is it no? Sorry, not 220. Let me see. Not 220. What would be the sample size for 300 and no? Should I do 300? No, 3010. What would be the sample size for 3010? 3010. Miss Lydia, I hope you got the question.
Yes, sir. We have 3,000, 320, 340. Please hold on, hold on.
Okay, okay.
Sorry, sir. I'm
Yeah.
with children.
Oh, sure. No, don't worry. I understand. I understand.
So with the 3010,
Yeah.
I have found 3,000, then I have found 3,000 and 320, 340 in that order.
I think what you are looking at is 300 and not 3,000.
Oh, okay, okay. So we have 3,000, 3,050. Said, I don't think there's 3,010. We have 3,000. I have 3,000 here, and then it jumps to 3,500. Oh,
Yeah, 3,500. Exactly. So the rule of thumb is that if you have a number that is not an exact number on the table, you pick the
mm-hmm.
number next, the sample size for the next one, for the next number for accessible. So in this case,
That is
since
the
this, yes, so if you have 3,000 and
3,000.
yes, so if you have 3,010, you would have to pick the
Mm-hmm.
sample size for 3,500.
Okay, to stand in for the 3,010.
Yes, to stand in for the 3,010. Yes.
Okay.
Yeah, so what then would be your sample size for 3,010?
That would be 346, 346. So
Exactly, exactly. So what would be your number? What would be your sample size for if you have an accessible population of 72?
72. Let's go here. 72. Okay. Then I think we will pick the 63 to represent the 72.
Yes, so then
S-
63 will be
Yes.
representative enough for a sample of 72, according to
Okay.
Creasy and Morgan
And okay.
1970. Yes. So that is
Okay.
how you use the Creasy and Morgan table to determine the sample size. Determine the
Okay.
sample
Okay.
size. Then
Okay.
we have, so if that is the case, I want you to tell
Hmm.
me what will be the sample size for the UCC SMS students. What will be their sample size?
What was? Can I go and see their number?
Yes,
Or is their
so you can go. I want you to try and figure out how you get their number from the sampling frame I've given
sam-
you. So the
okay? The
sampling
sample
frame is
size.
already there. Uh-huh.
Okay. SMS. Where's the SMS? There's the SMS.
Hello, sir.
Yes,
Um.
yes.
Sir,
oh,
please, I want to know the specific list that we are using. It's like I'm confused.
Yeah, we are using right now we are using the UCC. If you're on the page, I have this list here, UCC SMS. sampling frame SMS. Sampling frame SMS. This one, I've referred to it on the
Okay,
page.
okay,
Yeah.
sir.
So
All
what
right,
will be?
sir.
Yes.
So their total, the total number is 142. Is that right?
Okay.
That's the
E-
last number.
yes, exactly. 142
So
right here.
142. If we
Yes.
come to Cressy and Morgan, please can you put the table back on for me?
Yes, yes. Cressy and Morgan here. Right.
142. So if it's their size is 142, then we can use 108 as the sample size to represent the 142 of the
Uh,
UCC. Yes,
SMS. Good. So the
yes.
sample that for accessible population of 142,
Mhm,
108
mhm.
participants will be representative enough according to who? Cressy and Morgan,
Yeah,
1970.
Morgan.
Good.
Yes, sir.
So this is
Okay.
Sir,
this is
hello,
yes, yes,
Okay,
please.
so it's
hello, sir.
making sense, sort
Sir,
of.
please, with this, sorry
Yes.
to say this, please, can you go step by step for me because with this thing, I'm not that good, so you
Yeah,
can
so
do it
that is
step by
why,
step for
you
me
see,
so
that
that.
is why we are taking this as slow as we can. I think we ended the first session
That's right.
and then,
We
Yeah,
are
I joined,
scientists. Why
but I
are
couldn't
we
hear
now
anything. It's like
mathematicians?
I was confused all over.
Sir,
okay. Yes.
because of mathematics, I decided to do psychology. So why am I now
Aha.
being told mathematics?
Miss Lydia, unfortunately for you, mathematics is everywhere. Let me tell you, to be honest with you, personally, I wanted to come and do computer science because I love computers, I love technology. So a lot of people thought I was coming to do computer science. And to be honest with you, there are people who even think without asking. People think I'm a computer, maybe BEd ICT or computer engineering student because I do a lot of IT work. But when I came, yes, what you need to understand is in every single field there will be research. Okay, be it psychology, marketing, uh, look, agriculture, there will be what do we call research. And research, you either do quantitative or qualitative. If you are going to do quantitative, mathematics will be there whether you like it or not. So we need to understand the research when as it applies to psychology. And in psychology, most of our research, not all, but some of our research will be quantitative, some will be qualitative. So the quantitative one, you need to understand them. Even if you are doing qualitative, you see right now you are sample size determination. Even if you are doing qualitative, you may have to deal with numbers because you'll be talking about I selected this number of people because this person said if you are doing interviews, this is the number of people that will be representative. It's still a bit of mathematics. So this lady, as for the maths, we all don't like. If you were in the first
Yes.
session, yes, if you were in the first session,
But
I made a
but
mistake.
sir,
And yes,
please can you project everything so that we can see it from your screen?
yes, I'm actually projecting now. It's just I've switched back to your
But
this thing. I've switched back to the
and I can't see it from my end.
no, I've projected. So
Yeah.
you check from your end. Maybe you have switched to a different place. But Miss Lydia, you
No,
can
I'm
see
on it.
you can see the table, right?
Okay, I
Yes,
can see it. I can see it
yes,
now.
please. Yes,
Uh-huh.
please.
So that
So
is
let's
the
go
thing.
on.
Let's go on. Yes, let's proceed. So that is how you use the Cressy and Morgan table. Now, the next way to determine the sample size is using the percentage method, where when you are given a percent, you are given a sample. Okay, let just one last try before we proceed. What would be the sample size for UCC level? No, not level 400. The main list. I had a main list. I think that was that would be the last UCC sampling frame UCC list. The 50 megabyte file. This one.
Okay, okay,
Yes.
okay. So their population is that's a long list.
Yeah, it's a long list.
Their
Yes.
population
This. Yeah.
815.
Please come again.
Their population
29582.
no, it's the last page. Hey, oh okay, I'm not there.
Uh,
Oh wow.
you are not there.
29582.
You are not there. It's about 62 pages. So
Oh
yeah.
Jesus.
These were. I got this list from somewhere. It's actual students. So yeah.
Okay, so my last population is 2,958. That's Alasa Mustafa.
Yes. Now, based on this, what will be
Nine.
the assuming this is our accessible population, what will be our sample size?
Okay, sir. So back to the table. 2958.
Yes. Oh,
2958. 2958. Say please. So 2958. 2000. 2958. 29. So it will be 2958. It will fall between the 2,800 and the 3,000.
right.
Yes. So then we can use the representation of the 3,000, which is 341, to represent the entire population.
Good. That is how you see.
341.
You see, it's not anything difficult. So if it is more, you pick the second one. If it is the exact number, which
Yes.
in practice, chances of getting this exact number is actually slim. So that is why if it is more, you pick the next number.
Okay. Okay.
So
Okay.
that is that. All right. Now the second method is using the
Thank you.
percent. Oh, you're welcome. You're welcome. The second method is using the percentage method of calculating it, which we had demonstrated. So, for example, Amadahe 2001 recommends 10% of the, what do we call it, of the accessible population. So, if we
Yes,
want to
sir.
do 10% of the accessible population to calculate the percentage, and let me mention this. You realize that whenever you are calculating sample size, the capital N you see, as in the case of
Mm-hmm.
this capital N that you
Capital.
are seeing here,
Yes,
is
sir.
for the this is for the accessible population. The N capital N is for
As
accessible population.
accessible
Population.
population.
Yes. Then wherever you see this small n here, it's for your
Okay.
sample size. So the
Small
sample
n sample
is for the
size.
sample, yes, sample size.
Okay.
So and the
At,
sample size is, please come again.
oh, sorry, sir.
Yes, did you say something?
Oh, no, sir. Please, let's go on.
Okay, now let's say we are using the percentage and we are using the 10% recommendation by Amada in 2001. Then we want to calculate the sample size, which is n. So sample size, which is n, we'll divide the percentage, which is 10%, is that not it, by 100, and then we multiply it by the n. So let's assume we are calculating the sample size for the UCC, the sampling frame UCC list. What was the n? Miss Lydia. Uh, hello.
Sorry, sir. I didn't know I've muted myself.
Oh, don't worry, don't worry. So the N for the UCC list, no sampling frame UCC list. What was the N?
Was it the 2,900 and something something?
Yes, yes.
Yes,
Can you please double check
the
for me?
let me go back, please.
Okay, okay.
So okay, so our uh, our number is 2958. That's our sampling frame.
So our N,
Or
yes. So the sample
yes,
that is our sampling frame, which is made up of the accessible population. You said it's what 9.
2958. Two nine
Two
five eight.
nine five eight. Okay,
Yes, sir.
so we are using 2958. This is our formula. So if we are using
Okay.
2958, that you put the 2958 here. So
Okay.
2958. So 10 divided
Sir,
by
wait.
100. Yes.
Sir, wait.
Yeah.
So this formula we are using, they have chosen 10,
Yes.
uh, a 10, number 10 as what? Sorry, sir, I didn't get there.
By Amadahe,
Yeah,
I
by
can see
Amadahe.
by
You see,
Amadahe.
Amadahe recommended
Mm,
10%
Okay.
here. He says that
Yes.
if you have an accessible population, take 10% of the
O-
accessible population and use it as your sample.
Okay.
So we are coming to
10%.
calculate that 10% of our accessible population, and our accessible population is 2,958, as you have seen in the
I get it.
sampling frame.
I get
So
it,
that
sir.
good. So that's what we are now coming to calculate. So to calculate
That's
the percent,
10
yes, yes,
times the 2958.
58, yes. So when
Yes,
you are
sir.
asked to use the percentage, you can start this way. You first start by quoting the formula. So n is equal to the percentage divided by
Yes.
100 times the
Okay.
n, the big N, which is
Okay.
So,
for your
sorry
access.
for sorry to drag you back. With the
Yes,
zero was slash 6.
yes.
For
There's
that one is just a conventional formula for that.
you said 06. I'm not sure if I follow.
It's the percentage he's referring to. The
Ah, oh,
percentage.
oh, okay. Sorry, sorry. I
That's
think
it.
it's not 06. It's percentage. It's by handwriting there. Sorry, because I'm using a digital something. It's a bit tricky to.
Oh, okay. It's a percentage. Oh.
Yeah. So, yeah. I'm using a Android
Okay.
tablet, so I'm just using it for the first time. So I'm still trying to get a
Okay.
hang of it.
Okay.
Yes.
Okay. Thank
So
you, sir. Percentage
percentage
over
divided by 100 times the
100.
n.
Okay. The
To
N
get
is the total accessible population.
yes.
Okay, sir. I'm following,
So
sir.
so since you have it this way, you mean you have to know what percentage you are working with. Then you have to also know the n. What is the n for the accessible population? Then you just plug those numbers in. So to get our sample size small n, we divide this. So if you divide 10 by 100, you get 0.1, right?
Yes, sir.
Then you multiply this by 2958. So n is equal to, if you multiply 0.1 by 2958, what do you get?
I think you get the same number, although I don't have calculator here.
No, you won't get the same number actually.
Oh,
You
okay.
it's 0 point. So let me just let me do. I have a calculator here.
Okay.
So 0.1 multiplied by 2958, right?
Sir,
Yes, sir.
is 295.8. So it will
No,
be 29 running to
There's no point.
96.
No point.
hey,
There's no
sorry.
point.
There won't
It's
no.
0 point.
Yeah, so 0.1 multiplied by 2958. This will be equal
Sir, and I'm
to,
saying, and we will run it to 29296.
yeah, so 2958.8. Yes. So what he is saying is once you get this when you calculate you get 29295.8.
Oh, okay.
So our
Two
n,
nine
yes.
eight.
So our n here will be 2, sorry, you get 295.8. But since you can't have a decimal person, like who is the point 0.8? I don't think Miss Lydia want to be point 0.8. You
No,
have to
sir.
be a
I'm a fool.
uh-huh. You're a full person. So
Yes, sir.
we we have to round it to the nearest whole number. This I have to
Oh,
confirm from Doc whether we'll round it to the nearest whole number or we'll round it up or round it down. When they say round it up, that will mean we are around whatever number we get, irrespective of the decimal here, we'll increase this one by 1. If we say we are rounding
okay.
it down, if we are rounding it down, irrespective of the number here, we'll keep this number here. But if we are rounding it to the nearest whole number or rounding it off, meaning you check this. If this number after the decimal point is greater than 5, you add 1 here. But if the number here is less than 5, you maintain the 5, the number which is here. I don't know, Miss Lydia, do you understand?
Yes, sir. So
So
if we are running it up, we could make it 2529596.
6.
no, so
6.
296. You see, there's a decimal here.
Yes, sir.
Good. And the decimal is what do we call it? The decimal is simply telling you that this number here is not a whole number. So, but this has to be a whole number because you can't have a 0.8 human being or 0.8 element. So you have to round it. So I'm saying that if we are rounding it up, this one we are rounding it to the nearest whole number. The nearest whole
Okay.
number here is 29. Then if this is more than 5, we round this last number here to, we increase it by 1. So in this case it will be 6
Okay.
because this is
Okay.
5.
I get it.
So you add 1, so
Yes,
you
sir.
get 6. But if this
Yes, sir.
number is less than 5, if this number was less than 5, then we'll maintain we don't add anything here, we just take it off.
Okay. Okay.
Uh-huh.
We run
But
it off.
yes, yes. So that is how, if they say round it off, you are still doing what we are doing right now.
Okay.
Where if this number is more than 5, you add 1. If it is less than 5, you maintain what is here.
Okay.
It is when you are rounding it down, then whatever number is here, you maintain this. If you are rounding it up, whatever number is here, you add 1 to this.
Okay.
Uh-huh.
Okay.
Good. So
Okay.
this one we are rounding
Sir,
it to
please,
the,
you
yes,
said we are running, when we are running it down, you maintain the number.
yeah, the number here.
So
Irrespective.
if this answer is 295.8 and we are
Yes,
running it down, we will
yes,
still maintain the 295.8.
yes. No, you maintain the 295 and remove the point 0.8.
Yes.
Okay, okay,
So you have
okay,
run
I
it
get
Uh-huh.
that.
off. Mm.
You've rounded it down to the, like the lower one.
Mm.
So this one will
Okay.
be
Okay,
maintained as 5. But if you're rounding it up,
Okay.
even if here is 3, even if here is 3 and you're rounding it up, even if here is 3, as long as there's a number here, you increase this by 1.
Okay.
Okay.
But if you're rounding it off, or if you're rounding it to the
Off.
nearest whole number, whatever, whether you change this or not, depends whether this number here is greater than 5 or less than 5. Is 5 and above or less than 5. So if this number, if you are rounding it off, if this number is 5 or and above, you add 1. If it is less than 5, you maintain it. I take it again.
Understood.
Yes, so that right now we are rounding it off, or we are rounding it to the nearest whole number. So we are using this to determine, and this number is greater than 5. So we'll add 1 here. So n will be what?
296.
Please, do you understand, Mr.
So I get that.
Yes, Mr. Isaac? Yes. So
Yeah,
that
I'm still following, sir.
yes. So this is how you calculate for the sample size using the percentage.
Okay.
So with this information, I'm going to give you a different question from here. Let's say you have this one. If I put it in the chat here, will you guys see it?
Yes, sir.
Yes, sir.
Right.
Yes, sir.
Yes. So try your hands on this one and let me see.
Sir, it's gone. Or I should go where?
No, it's okay. You want me to? Okay, you let me
Where?
place it here so that let me place it here so you can see it well.
Sir, put it on your screen.
So that's this particular question here.
Okay, so population nine thousand 9,800. Because of the logistics, researcher limits the university. The population of 870. Use 15%.
So in other words, using
So
15%
what
to
does it
calculate.
mean if you say
Yeah, so that's what I'm trying to
so
say.
what does it mean? Use okay,
Use
okay.
15% to determine the sample size, or to calculate the sample size. I could use determine to make it a bit more ambiguous, but I still expect you to understand. But that's what I'm trying to say.
So this one we are not going by the 10%, but 15%.
Yes, please.
Oh, okay. Okay, so n equals 15 times 100 times 870. N equals 0.1 times um, times 870 equals. Where's my calculator? Um, okay, so 0.1 times 870. Will that be correct? 57. Will that be correct? Hey,
Yes, I'm listening.
Okay, so with my working is 15% um times the 870 population, which gave me per my phone calculator. I don't know whether that calculator will work with the decimal or the 0 point, but it gave me 87. But it's
Okay.
calculated the 0.1 well. Oh, okay. Because I don't
Okay.
have the normal calculator with me, sir.
No, your phone calculator should be just fine. Your phone calculator can also calculate it just fine.
Oh,
So, what was the
oh,
sample,
okay.
the total
So
sample
then
size
it's
you got?
I'm sorry, I'm wrong.
Okay. Well, I'm glad you
Oh,
figured it out. So,
yeah. Now 15%, 15 divided by 100. That's how I should go
good.
about it. I
Yes,
use the
exactly.
10%. Aha.
You see, that is
Hey,
how mathematics is. So, and that's why we
this
people.
mathematics, I'm understanding
Yes.
it
So,
more.
yeah. So let's see.
So where do I clean? Okay. So
Yeah.
15 divided by 100, it gave me 0.15. Okay.
Sir,
Yeah.
Equals 0.15 times
hello, sir.
8.
Yes, please. I'm listening.
Sir,
So
the answer is 130.5.
130.5.
So approximately,
Yes, sir.
131.
yeah, Miss Lydia, you still have to approximate it. So the point five is not final because you can't have a point five. Uh-huh.
Yes, sir.
So you have to
Yes, sir.
then say. So usually when you're even writing this final one, the mathematicians say you shouldn't write it equal to. You have to write it approximation. So you do this wiggly lines. So approximate n is approximately 296.
Okay. Where's your
Uh,
wiggly line? Okay.
it's
One.
here.
Okay.
So wiggly lines like that, and then you write 290. It's when you round this, then you say it's
Okay.
approximately 296. Yeah. Uh-huh.
Okay. So then this, we will get approximately 131.
Yes, approximately 131. Exactly.
131. Mhm.
Yes. So
Okay.
that is how you use the percentages in determining the sample size.
Okay.
I hope
Okay.
you are clear on that.
So it's
Yes,
one. Why
You
am I
said?
understanding this mathematics so easy?
Oh, it's easy. Oh, it's
sir.
easy. It's just that
I'm
sometimes,
not.
sometimes it's
Let me
the
tell you. Let me tell you something.
okay.
I get through the mature entrance,
Oh,
and
okay.
on the mathematics side, I employed a mathematics teacher. I think for 6 weeks, all
Wow,
throughout the. Yes, sir.
wow.
For 6 weeks, and I think we met 3 times a week because I
Okay.
had no clue.
Oh, okay.
So that's why
I
I'm
I
I'm like that. Mass.
I understand. I understand. Trust me,
Thank
personally,
you.
I have hated mathematics from JHS till I came here, but I've come to understand that sometimes it's the fear of the maths that makes it difficult for us to even understand it because you spend so much time
Yes.
thinking of how difficult the
Feeling.
thing
Yes.
is rather than
Yes.
taking time to understand it.
Yes, sir.
So it's very normal. It's very normal. So
Yeah.
let's say now we have calculated our we've
So let's
calculated.
try one
We should try one
Hello,
more.
hello, sir.
Yes,
Hello,
more before.
sir.
yes,
Hello, sir.
yes. I can hear you. I can hear you.
Sir, for what you are doing for us. So,
Yes.
say, I will send you some credit because of what you are doing for us. Because
Oh,
sir, it's not easy.
I'm just doing my job. Oh.
I know, but for what you're doing, I need to send you some credit.
God
I'm
bless
just
you, Isaac.
I will do that.
Okay, all right. I hear. Thank you in
Okay.
advance. Anyways,
Okay.
let's say now, Miss, we've determined our sample size, but remember, from here, I told you that the sample size, just so you know, is not when the one you've calculated whether it is probability or non-probability. That is how you determine the sample size. I'm
Okay.
going to say this again. Whether it's probability or non-probability, that is how you determine the sample size. Because even if you are going to do convenience sampling or purposive sampling, you still need to
The
know how
formula
many
that
people. Yes,
okay.
yes, the formula. You still have to know how many people you are selecting, because whether probability or non-probability, you need to know. You need to estimate your total accessible population. Then based on that number you determine how many people you should include. So that one is whether probability or non-probability, whether you are doing convenience or systematic simple random, you have to determine the population, the sample size. Sorry, you have to determine the sample size. Now
Okay.
once you've determined the sample size and you are using the probability sampling techniques, meaning you have to have the sampling frame. Okay, once then when you have the
Okay.
sampling frame and you are using the simple random sampling and you have the sampling frame, so let's take for instance we are using this UCC list. When you are using the simple
Okay.
random, what happens is, you see, I've given them unique numbers all the way to the last number. You can
Yes,
use
sir.
a random number generator. So there are softwares that you can put the range, so from 1 to, let's say, the last number, which in this case is 2,958, and then you tell the
Yes, sir.
random number generator to be picking any number at random between this
Okay.
range. And if
Okay.
you pick up to, so if we were using the Cressy and Morgan, what was the number we picked? 300 and, was it 329? So we took 400 and 341, right?
Yes, sir.
So you
Yes,
tell it
sir.
to pick 341 participants from this list at random.
Okay.
So
Okay.
what
Okay.
the system would just be doing, maybe it would just kind of pick 2,692, go and pick
Okay.
2,671, then maybe scroll all
Mhm.
the way up, pick another number from around this range, 1,121. So if it picks whatever number it picks, you look for the person. So this is Daniel Opong.
Okay.
1,191 is Daniel Opong. So Daniel Opong might have a contact number here. So whichever number you pick,
Okay.
you pick the person's contact number and you reach out. We want you to participate in this our study. We
Okay.
want you,
Okay.
maybe pick number 22, then you contact Boatin Solomon. We want you to participate in the
Mhm.
study. It pick number 83. You contact Upon Nana Kwabena. We want you to participate in our study.
Oh,
So the
and this to prevent not being biased.
yes, so that you are not biased.
Okay.
So you are
And
not biased.
somebody can also replicate your work. So your work can be replicated.
Replicated, yes. So the person knows that, okay, when you were doing your work, you used a random number generator. So the person also go and use a random number generator, put their sampling
Okay.
frame in. It will do this a similar thing, and then the person
Okay.
also get your number and then replicate your study. If, let's assume
All right.
this sampling frame is for university students, so if the person is also replicating, they will also get a sampling frame for university students and use the same random number generator to also select their participants. Yeah, you get it.
Yes, sir.
So that
Thank
is
you.
if you have a very huge sample size like 231. If it is a small sample size, let's say your accessible population is around 200. If it is 200 and you are using Cressy and Morgan, that is just around 132. Let's even break it down. You have an accessible population of, let's say, 40, and you are
Okay.
to pick 36 people. Instead of using the random
Mm-hmm.
number generator, you can even do the lottery. So you write these numbers here, 0 to the sample size of, what do we call it, of 36. Then you put it in a
Okay.
box, you shake, 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 shake. No, so you write,
Okay. Okay.
what do we call it, 1 to 40, which is here,
Okay.
1 to 40.
Yes.
So you shake, shake, shake. you remove one person, put it down, shake, shake, shake. So you do that until you get the 36. So
Okay.
whichever numbers are left in the box, those people will be excluded. Then the numbers you have removed, you come to this list,
It's
then you unwrap it. When you unwrap it, the number you have taken, maybe you chose number 36, you contact Mr.
mm-hmm.
Emmanuel. You chose number 15,
Mm-hmm.
you contact
Mm-hmm.
Asma, Hati Asma. You chose number 31,
Mm-hmm.
you contact Clement. So that is how you do the simple random sampling, sampling when you are doing research.
Wonderful.
Yes, that is when you have the sampling frame. That is why it's important that when you're using a probability, you choose the sampling frame. And everyone has an equal chance because it could be him, it could be Ayisi, it could be AC, it could be Frema, it could be Levy, it could be anybody. They all have an equal chance because you have their
Yes.
list. Uh-huh.
Yes, sir.
Now, the second method of the probability sampling is what takes us to the second calculation that we were doing, which is the systematic random sampling. That
Is
one
that
too,
okay?
yes, systematic. So that one too, everyone in the population has an equal chance of being selected. Okay, and just that one you do it in a more systematic form. There's a whole step to it. It further reduces the bias that you were mentioning. So you
Okay.
start you start with let me just open to do that. First thing you have to do, I hope you can see this.
Yes, sir.
First thing you have to do is to calculate your sampling interval, and we will look at
Okay.
that. The sampling interval is denoted by K. Just as
Okay.
remember, our sample itself is denoted by N, and our
Yes, sir.
accessible population is denoted by N. This sampling
Yes, sir.
interval is denoted by K.
Okay. That is sampling interval.
Yes, that is for sampling interval. Then, for the second step, after you have calculated the sampling interval, which you calculate by dividing the accessible population by the
Okay.
sample size, you then pick a random number. Step 2, you pick a random number that is not the first person on the sampling frame,
Okay.
but also not greater than the sampling interval you will get. So the first person you pick should not be the first person, and shouldn't also be then the number you get when you divide this by this. It shouldn't be greater than that number.
Okay.
That first number you will pick, you go to the sampling frame. So let's say I have calculated my sampling interval and I got, let's say, 10.3, which I'll round to 10. Is that not it?
Yes, sir.
Then you pick a random number. So whatever number you pick should not be greater than 10, but shouldn't also be number 1.
10.
Yes.
Okay.
So
Okay.
let's say I decide to pick number 6. So that number 6 will
Okay.
be my first person to be included in the study. So if I were to use this particular sampling frame, that number 10 will be who? Atiapa Emmanuel.
Is that
You
number
see?
6?
Hey, sorry.
Ebenezer.
Good, good. I'm glad you are following. I am very glad you are following. So
Want to understand.
number 6 is Ebenezer Mensah.
Yes,
Yes.
sir.
Thank you very much for the correction. Ebenezer Mensah. Then, once you've gotten Ebenezer Mensah, you then add the third step, which is the final one. You add the sampling interval to the first random number. So the sampling interval
That's
was 10. So you add it,
okay.
you get what? 16.
16. Okay.
Who is the 16th person?
Kingsley
Kingsley
Kuju.
Krakujo will be your second element.
Okay.
Kingsley
Then
Krakojo.
you, yes. Kingsley Krakujo will be your second element. Then you add the sampling interval of 10 again to the
Right.
16
Okay.
to get
Okay.
what? 26.
Yes, sir.
Good. So the third element or the third participant will be what? Ayisi Kwame Interi. So you keep doing that till you get your last person for the sample. Please, is that clear?
Yes, sir.
So now what we
So,
are going, yes, yeah,
is this the third formula?
no, so this formula, you use it
Is this part
after.
of that?
So that's why I'm trying to explain that this formula, you use it specifically for systematic random sampling. That
Oh,
is
okay.
after you have determined your sample size, which you would have done here.
Okay.
Then you need a way to select the people. So the simple random, you just select at random. Systematic, you still need to use some form of calculation to select the people. Remember here, you were not selecting anybody. You were just simply trying to determine how many people I am going to select.
Yes, sir.
Now, the systematic is going to guide you to actually select the people. Like, who am I
Oh,
selecting?
okay.
So,
Now I get
so,
it.
so it's not a third formula. It is just a way to select participants.
Okay.
Which is why you
Okay.
see in the formula, good, good, good. So, if you have gotten that, you can then, so let's pick this example and use it to calculate. So let's use this UCC SMS. The UCC, should I use the UCC SMS? How many students were UCC SMS? Or you know something?
Say.
No, let's use this. Let's use this particular list that I have here. I'm going to send this list to you guys right now.
Okay, on the page.
Yes, on the page. I'm going to send this to you right now. Good. PDF.
But that's the SMS frame, sir.
No, this is actually
When
interesting
I,
thing. This is there?
when I tap it, open the SMS file.
Oh no, I'm yet to send it. You just give me a second. I'm actually yet to send it.
Okay.
Yes. I'm actually yet to send it. So just give me a quick second. I'm just copying the names of the schools and including the what do we call it? Let me clear all formats.
That's
Oh,
it.
sorry. Okay. Insert table. Good. So I don't know why it's doing this, but we'll manage it like that. Okay. Schools. Sisala West. Schools. Says. Shit. Good. So I'm putting this on the page.
Okay.
Good. So open it and let's try our hands on it. Good. Have you opened it?
Yes, sir.
Good. So these are actual schools from my district, Sisala
Okay.
West. And we got
Okay.
this sampling frame last 2 or 3 months ago when we went there to collect data on basic school students. So it was covering basic 1 to 3, and that
Okay.
was your facilitator is the one handling that project, and she used
Oh.
cluster sampling. But to do the cluster sampling, we did some. Let's assume that these schools are clusters, like they are clusters of schools. But let's assume for a second we are going to use systematic sampling to select schools from this particular frame. So this is a list, which is the sampling frame. So we are going to use systematic to select certain schools from here. Okay.
Okay. Okay.
First of all, how many schools are there?
66.
This is
Good. So what will be our sample size according to Kretzy and Morgan? Because remember, for us to calculate our sampling interval, we need to know the sample size.
Yes. Yes,
Good.
sir.
So what will
So,
be
and Cressy and Morgan table. Okay, 60. Okay, you've input it there. Okay.
yeah?
So 66 is between 60 and 60. So then we can use 56 to
Good.
represent. No,
Good. So yeah.
we can use 59 because
Uh,
60
uh-huh.
says it's between 65 and 70.
Exactly. So we have to move to the
So
71, which is 59.
59. Yes, sir.
Yes. So
Yes, sir.
our n
So
is what? So our small n here is
yes, sir.
59. The big
9,
N here,
50. Mhm.
66. Is that it?
Yes, sir.
Good. Now, now that we have this information, we can then
Mm-hmm.
calculate the sampling interval, which is
Okay.
K. So K
Okay.
will be equal to
Go
66
to 66
divided by
divided by
59. What will be
59.
the results of this?
Okay. Where's my calculator? Uh,
the 1.11.
Yeah,
but
we are going to. Yes, I'm seeing that this is not going to work very much. It's not going to work well. Now, good. This brings me to one important reason, which is where when they say when is it appropriate to use which sampling method.
mhm.
This is important because you when you have a small sample size, you don't use systematic. You use the simple random sampling.
Okay.
But when you have a large sample size, that is when you can then use the systematic. Because as you can see from right now, you see what we had 1.29, which is we also said when you are selecting the random number, which is step 2, we can select number 1, and we can select above the sampling interval.
Best one underwear. So put your panty. And basically walk around in the house. You have time.
Okay, so with this, we are going to change the scenario from this because the sample size is too small. The accessible population is too small for us to use the systematic random sampling. Please, are we following?
Yes, sir.
Yes,
Yeah.
sir.
When the accessible population is small, like in this case, you use the simple random sampling. That is one of the reasons why you choose to use the simple random sampling. Okay. So we are going to use let me give you a different. So let's use this UCC SMS, the SMS people. They are what was the N, what is the N for the UCC SMS people?
It was 2,958, sir.
I think that is for the general one. The SMS
Oh,
was, yes, yes.
um, was it 296? That was
Yes. Yeah,
296.
let me confirm that from here. Yes, two, no, 142. 142. They were 142.
Okay, the
Yeah,
other
they
one.
were 142. So
Yes, sir.
the big N is 142. The small n, which was the sample size we determined using Cressy. No, let's use the 10% sample size. The 10% sample size of this was
Um,
0.1
the book.
times 142 was 14, because it was 14.2. So rounding it off was 14. Please, do you understand?
No, you are using me, sir. I don't know what you
Okay,
are doing, where you are doing.
okay. I said the n we agreed was 142.
That is the
SMS, UCC
the
SMS here.
site. Yes, sir. Yes, sir.
Uh-huh.
Now,
142, yes. So
yes, sir.
142, and I said we are calculating the we are using the Ramadan here 10% of 142.
Okay,
So
okay,
10%, that is
okay.
10 divided by 100. That's 0.1,
Yes,
right?
sir. Yes, sir.
The times
Yes, sir.
142 will give us 14.2.
Yes, sir.
But we'll pick 14.
Okay,
So that will be our sample size n.
okay,
So what will be our sampling interval? Our sampling interval will be the big N 142 divided by the small n, which is what? 14. So if you divide 142 by 14, what do you get? You get 10.14.
okay.
10.14. So let's just do that here. So if you take, that is when you take 142 divided by 14, you get this. So if you press, if you are using a scientific calculator, you have to press this SD to get this. So 10.142. So rounded to 2 decimal place, 10.14. So 10.14. But as we said, you can't have a decimal, so you have to approximate it. So therefore, K is approximately 10.
Yes,
Good. Now, since we have our sampling interval, we then select step 2. Select first random number that is not the first and also not greater than the sampling interval. So, what number do you guys suggest we select?
but it's not one and it's not bigger than 10.
Yes.
5, sir.
Okay, 5. So, 5. So, 5 will be equal to, so let's say, so you can just type something like, say, random number is equal to 5, which is equal to first. So that will be your first element. Remember that
Yes,
first
sir.
element is the random number.
Yes, sir.
Good. Then to get the second element will be equal to
5,
5 plus the interval. So 5 plus k which is where
Okay.
k is equal to 10. So 5 plus 10. This is equal to 15th person. Then the
Okay.
third will be equal to 15 plus 10,
Plus 5.
which will be equal to 25.
25.
So 25th
Mm-hmm.
person on the this thing, sampling frame. The fourth person will you be, do the same thing. 25 plus what?
Plus 10, sir.
Good. That gives you 35th person on the sampling frame. So you keep doing that until you get your what do we call it? So you keep doing that until you get your 14th 14th what do we call it? Participant, because you are selecting 14 people.
Yes, sir.
Good. So you see now if we are using the sampling frame, the first person is number 5. So you go to number 5 and then you pick this index number SMS 170036. That
Mm-hmm.
will be your first participant. The second one
Yes,
is
sir.
15th. So you go to 15th here.
Mm-hmm.
SM
Yes, sir.
SMS 18. So like that. So after every 10 you pick. After every 10 you pick, which is what was being demonstrated here. After every two you pick, after every two you pick, after every two you pick. That's what this demonstration is trying to talk about.
Yes, sir.
Please, are you
And
clear?
it was in our no, it's in our notes. Yes, sir.
Yes, yes, yes. So that is how the systematic random sampling is. So you could get a question where they will say that, for example, I have a certain question here that she said. Um, Let me just read it out. The question goes something like this. A researcher uses systematic random sampling procedure from a company directory that has 600 employees. If a desired sample is 20, what is the sampling interval? So all you have to do is divide the 600 by the 20 to get your
Okay.
sampling interval. And
Oh,
then
okay.
she proceeds to ask, if the first name selected is number 8, what are the second, third, and eighth elements to be selected? So
Okay.
once you've calculated your sampling interval, so let's say you've calculated the sampling interval, she said the directory has 600 employees divided
600.
by your n, small n. The desired sample is 20. So you get what? 30. You get exactly 30. 30 becomes your
Oh,
sampling interval.
oh, okay.
Then so you pick the random number that was selected. If the first name selected is number 8, what will be the second? So you add 30 to 8. So 30 plus the sampling interval, sorry, 8 plus the sampling interval. So
Okay.
first number is 8 plus sampling interval of 30 to get you
That's it.
38.
Hmm.
Then the third interval is 38 plus the sampling interval again to get
30.
68.
That's 68. Okay.
Yes, so the 68th person will be the third person. Then the eighth, to
Mm-hmm.
get the eighth person, you repeat till you get to the eighth. Then you say the eighth
Okay.
person will be there. Then you add. So you put the number there.
Okay.
So whatever you are doing, you have to show working. Even if you see the number 8th, you would have to calculate for the fourth person, the fifth person, the sixth person, the seventh person, and calculate for the
Yes.
eighth, and then say so therefore the second person is the what do we call it? The 38th person. The third person will be the 68th person. Then the eighth person will be the 100 and whatever, or 200 and whatever person.
Yes, sir.
Please, I hope you understand.
Yes, sir.
Are there any questions?
Hmm.
Thank you, sir. It sounds clear. But once the master, the old CMB now coffee.
So I when you
Yeah,
go,
will you have another class to repeating this thing? Optional class, no, is it about the same just to because I don't think they will be teaching you just a session. I'm will be at like you did this one.
yeah, so
You have
I've
another
actually
session
recorded
on.
I've recorded this. I've recorded my session with you, which is about an hour
Oh,
20 minutes by my time. I will save it somewhere, and if you have
okay,
data, you can go and watch it. You can just download and
okay.
watch it.
That.
Yes, but
But
tomorrow,
it's very simple.
yes, but tomorrow, what will happen is I told them that tomorrow I've explained this. I had given them an exercise that they were having issues with, so I didn't record it. But tomorrow I will give you a question on this. I will prepare a
Okay,
sampling frame. I will send you the sampling frame tomorrow. Then I'll give you a question on that sampling frame, and then you use it to answer. You use the same formulas to answer the questions.
okay.
Yeah. I hope you are clear.
Yeah, clear, sir. Thank you.
All right. Are there any questions, Mr. I don't know if you are still with us.
So I'm still with you, sir.
All right. I hope, are you clear on it?
So I'm barely clear, but I will take it like that. Since we will be having class tomorrow, I think I'll catch up
Okay.
tomorrow too.
I
Mm,
will send you the recorded session, Mr. Isaac. I would
okay.
entreat you try and rewatch it. And if you have
Okay, sir.
questions, you can just send me a WhatsApp message.
Okay, sir.
Hey, say what Benson who so aha. So what Benson is still, oh, she's not here, but her phone is here.
Hmm.
I don't think John Owuzu, are you with us? Okay, I think Mr. John is also not there. Their phones are around, but Oman Kasa there. All right, so if there are no other questions, I'll end this session, and then we will meet tomorrow. When we meet tomorrow and I give you the exercise, after the exercise, I would